Good morning, students. We are going to discuss about mobile computing for 5th semester students of Diploma Engineering and IT. So in the previous class, we studied about various types of architecture in mobile computing. We discussed about client-server architecture. Then we discussed about three-tier architecture. Then we discussed about entire architecture. We talked about peer-to-peer architecture. Now, today we are going to talk about the last but very easy kind of architecture, which is mobile agent architecture. Now, what is a mobile agent architecture? See, in all these architecture, in client-server architecture or any other type of architecture, the basic was that we had a client which was requesting for service, request, and there was a server which was providing service, or we can say it was giving some response. Okay, so this is the basic of the first three architecture, in which one system has some role to play, specific role to play, and the other system has some other role to play. They have different capabilities, different powers in terms of what they can do. Okay, but in peer-to-peer architecture, every system, there is a network between n number of systems in which the roles and responsibility, or we can say the capability of each of the system connected to the network is same. That's why they are called peer-to-peer. Peer means friends or someone who is having same capability as the others. Okay, so that's why it's called peer-to-peer architecture. But in mobile agent architecture, what happens is that whatever service you want, that is made available to you in the form of software. So what happens in mobile agent architecture? In mobile agent architecture, the service is available in the form of a software. Okay, it is such kind of software in which is directly available in your mobile devices. It is directly available in devices. In the device, it is directly available. The software has certain properties such as it doesn't need user intervention. The user need not know entirely what it is. It just has to know about how to, use that service. That's it. How the service is doing its work, we need not interfere with it. It is something like in client server architecture, what do? We have to, suppose you want to shop online, then you have to know certain details, right? You have to know that you have to go to certain e-commerce website. You should be able to do the ordering process. You should know how to look and choose and add things to cart, and how to check out and pay for it. Okay, how to track the delivery, and eventually you have to collect the product as well. That's the end-to-end process. So the user has to be invested in that. We have to participate in order to gain the service. But here it's not such the case. We need not even have to download or install or load the software into the device for the service. The service is what? The software. But we do not have to even download or load it. It maintains its own life cycle. So what are the properties? First thing, that it is directly available. Second, load. The user need not load it. And thirdly, uh, it is totally abstracted. Abstracted means we do not need to know the detail. What is abstraction? You might have studied in Java. What is data abstraction? That means we have to know just the output or what it does, how it does, what are the code details, we need not interfere. So same is the case. The user need not know how the software is doing something or what is the process. It is simply available. We have to just use it. It is available to us, we can say, in a most abstracted manner, that we do not know how it does, what it does. We just have to, it has to be available so that we can make calls. Okay. So in order to do something, mobile agent service is directly available in our handset, or we can say devices, whatever the mobile devices, it is directly available and we need not load it. Okay, so we can think that it's just a piece of software in which we can, with the help of which we can work seamlessly, but what it is doing, how it is doing, we do not know. That is, it is totally abstracted. Okay, so these are the key point about mobile agent architecture. So here we have come to the end of the various architecture in mobile network. Okay. So we studied the 4 and 5 kind of architecture. Now we will move to our next topic, that is wireless transmission. Okay. So although you people have some idea about what a wireless transmission is, because in the last semester in computer applications, we studied about wired and wired wireless, communication, in which we talked about guided media, unguided media. So wireless transmission happens through unguided media. Okay. So we will briefly discuss what is an unguided media is. See, there can be two types of transmission. As I said, it can be wired and wireless. What happens in wired? In wired transmission, we have to send the signals. What signal ultimately? That we will talk shortly about. But data is always sent in the form of signals. Now the signals travels through some medium. Okay, the signal has to travel through some medium. The medium can be a guided and unguided. Okay, what is guided medium? Guided medium is through which the signal propagate, but it is not air. That is, we are channeling it through some kind of wire. So the wire can be of various types. So in guided medium, we generally propagate the signal, that is, we transmit the signal. The signal travels in a wire. So the wire may be twisted pair cable, it may be coaxial cable and fiber optic cable. We have studied all this. Okay, I'm just recollecting, refreshing your memory. Now, here our focus is in mobile computing. We usually opt for what kind of medium? Unguided media. That is, we are focused on wireless transmission. Wireless transmission happens in unguided medium. We do not use any kind of wire. The signal is transmitted through air. Okay? So we will largely focus our discussion in what helps us in propagating the signal through air. Okay? So followed is the discussion about what a signal is, its properties, tools, tools used for transmission. Okay, so we will discuss about all these things. We will cover mainly about signal and its properties. Okay. So what is a signal? Okay. Signal is nothing but, we can say, it's a sine wave. Okay, signal is a sine wave. Okay, so we have light as an electromagnetic wave. Okay, there are various components of light. Okay, in light, depending upon a property called frequency, light is divided into various types. Okay, there are various types of signal in light. Okay, so V, I, V, G, Y, O, R. So they vary in their color. Some rays have violet color, some has indigo color, some has blue color, some has green color, some has a yellow color, and some has orange followed by red. Okay, and all these rays, okay, in the sunlight, all these rays have various frequency as well. Okay, so what is frequency we will understand, but all you need to know is signal is a sine wave. It is a part of light. In general, we call it a signal. A signal, light in general consists of 7 types of signal. They have various different properties. They have different color and they have different frequencies. Okay. So signal is generally of 2 types. Okay. Signal can be of 2 types. Analog and digital. Okay. What is the analog signal? It is typically this signal that we imagine, that is a sine wave. So how to differentiate between analog and digital is that in analog signal, signals are continuous. Okay, the change is gradual, it is continuous. But in digital signal, unlike analog, the change, that is the change it is making, the behavior pattern is abrupt. Abrupt means it looks like this. So this is the time axis, we can say. How does with time it changes? So these are the property of signal. It is called amplitude. That is the height. And this is the period. What is period? Period is time taken to complete a cycle. Okay, so the change is gradual here, but here the change is abrupt. Abrupt means it carries some voltage. We can say it is a voltage, or you can say energy as well. Okay, so it is 1 at times and suddenly it changes to 0. This is called abrupt change. Then it stays for 0 for some time, again it abruptly changes to 1. But here the change is gradual, don't you see? Suppose we call it high energy and this is low energy. The change from 1 to 0 is gradual. It takes some time to go to 0. But it happens suddenly. Within that second, it is changed from 1 to 0. Okay, you are understanding the difference between analog signal and digital signal? So this was all about it. Now we will study about property of analog signal. Okay. First of all, in light, naturally we are provided with analog signals. Okay. There are various types, as I said. It differ in some properties like color, frequency, on. We will get into those details later. But first of all, we have to understand what is naturally given to us. What is naturally given to us? Analog signal. And we will discuss its property now. Digitalization of signal happens later. We need some extra circuit. That is, we need some extra hardware to convert an analog signal to digital signal. Okay. So digitalization we will study later. First of all, we will understand the property of the analog signal which is inherently given to us by nature. Okay, so as I said, this is period. What is period? Period is the time taken by a sine wave to complete one cycle. Okay, that is what a period is. Now with period, relating period, I can define frequency. What is frequency? Number of periods that or number of cycle the wave makes per unit time. So what is frequency? Number of cycles per unit time. That is how much number of cycle the wave completes in 1 unit of time. You can define 1 unit as 1 minute, 1 second, or 1 hour, whatever you may feel like. But how much cycles is complete in that period of time is defined by its frequency. Okay. So to give a better idea, some signals, as I said, in light there are various types of signals. Some signals may have frequencies in which, suppose we are defining time in terms of second. This is 1 second, this is 1 second, this is 2 second, 2 second, 3 seconds, up to 3 seconds. Okay. So now suppose this is the frequency of one wave. Okay. And this may be the frequency of another wave. So okay. So how much time it is taking to complete one cycle? It is completing, what is the frequency we can say? One cycle in 1 unit time. The frequency is 1. What is the frequency of second signal? The frequency of first signal is, it is completing. You can see, observe please. One cycle is completed in 1 unit of time. So the frequency is 1. What is the frequency here? It is completing half a cycle in 1 minute, isn't it? So one cycle is being completed in 2 times. Okay. 2 times it is taking for one cycle. In one time, it is completing what? Half cycle. So what is the number of cycle in 1 unit of time? It is half, isn't it? So the frequency is half here and the frequency is 1 here. It has frequency what? 1. It is frequency half, isn't it? It is less frequency. Okay. Suppose I have wave, then its frequency is what? Suppose this is 1 unit of time. Okay, 1. How much cycle it is completing? 3 cycles, isn't it? 1, 2, 3. So the frequency here is 3. Okay. So this is how we measure frequency. So essentially, what is frequency? Frequency is the number of cycles made per unit time. Okay. So in this class, we studied mostly about signals. What are signals? What is wireless transmission first of all? And in wireless transmission, we use unguided medium. Unguided medium means the signal propagation is done openly in airspace. Okay. So what is the nature of signals we studied? What are the type of signal we studied? That we have analog and digital. And what are the properties of analog signals we discussed? It has an amplitude, it has period, it has frequency. Okay. So that is it. We will continue in the next class. We will discuss about the propagation, how the propagation takes place, the tools used for propagating signals, and some various other properties such as bandwidth of signal. Okay. Thank you.